Hello everyone. Today we are going to see the theory part 1 of the chapter Alcohols, Phenols and Ethers. So let's begin today's topic. NCERT chapter 7 Alcohols, Phenols and Ethers theory part 1, and specifically we are going to cover today the NCERT section 7.1 to 7.1.3. This is disclaimer. Let's first of all, because this is beginning, this is the first day of this chapter, let's understand that how can you prepare for this particular chapter for the competitive exams. So first of all, you have to cover the basic concepts, which includes basic concepts and definitions. You have to focus on the basic concepts and definitions from this chapter. You have to learn the classifications. You have to learn the mechanism also. There are various types of mechanism reactions. So focus on the reaction mechanisms, reaction rate, and the intermediate steps which are included in the reactions of alcohols, phenols, and ethers. You also have to focus on the distinguishing test like Lucas test, FeCl3 test, iodoform test. They are the tests which we used to distinguish among the alcohols or the phenols. Important points to remember. First of all, the acidic nature comparison between the molecules, their boiling point trends, and the reactivity order, and the common industrial uses, also the structural isomerism. These are the important points that you have to remember while studying this chapter, alcohols, phenols, and ethers, for the competitive exams. So these are the main, you can say, topics on which you have to study. Okay, so some basic concepts and definition, some classification, some reaction mechanism, reaction rates, intermediate steps, some distinguishing test we also going to cover in this chapter, and you should also have to learn these distinguishing tests. Also some points to remember like these, like their acidic nature comparison, their boiling point trend, their order of reactivity, their industrial uses, and their structural isomers. Solve practice problems on the topic like IUPAC naming, conversion reactions, distinguishing tests, mechanism based questions, and previous year questions. So particularly if you want to practice the problems on this chapter alcohol, phenol, and ether, you can focus on these topics: IUPAC naming, conversion of the reactions, like from one thing to another thing, you are converting one molecule to another. Some distinguishing tests like between the primary, secondary, or tertiary alcohol, right? And some mechanism based questions you also have to practice, and also remember to practice the previous year questions for the competitive exams you are preparing for. Okay, let's see the learning objective of today's lecture. So after attending this lecture, you will be able to classify the alcohols, phenols, and ethers. So today we are going to focus on the classification of alcohols, phenols, and ethers. The topic to be covered today, according to the NCERT, first of all, introduction. We briefly introduced the alcohol, phenols, and ethers. Then we will cover the section 7.1, that is classification, in which the subsection 7.1.1 comes, that is alcohols, mono, dia, tria, or polyhydric alcohols. We study what are they. And then we also cover the next subsection 7.1.2, phenols, mono, dia, and triahydric phenols. And then we also cover about ethers, the subsection 7.1.3. And then we will practice an in-text question 7.1, also then text question 7.2, and then we will end up with the summary. We will conclude with summary. Okay, so let's start with the little introduction about the hydroxyl compounds. Hydroxyl means OH group. Okay, so replacement of hydrogen atom in a hydrocarbon by the hydroxyl group gives you the alcohol. Okay, so alcohol means there is a presence of hydroxyl group in our molecule after the replacement of hydrogen atom from the molecule. So if you can see the reaction where, or you can say conversion, where the propane 3 carbon chain CH3 CH2 CH3 and one of the hydrogen of this carbon is replaced by the hydroxyl group, and you get propanol. Okay, all is for the alcohol. Okay, so this is propanol, 3 carbon compound containing hydroxyl group. This is propanol. If you see, this is found, like alcohols are found in sugar, in the cotton fabric and starch. Hydroxyl compounds are of two types. Okay, so we are talking about hydroxyl compound, not specifically about alcohols. Alcohols is a you can say type of hydroxyl compounds. Okay, hydroxyl compounds means containing the hydroxyl group after the replacement of hydrogen atom from the molecule, and they are found in sugar, cotton fabric and starch. And the hydroxyl compounds are particularly two types, you know all. First is alcohols and the another one is phenols. These both type of hydroxyl compounds are containing the hydroxyl group, that is OH group. Let's first define the alcohols. OH group is attached to an aliphatic system, that means saturated carbon system. OH group is attached to. For example, we have this methanol, 1 carbon containing compound having hydroxyl group in it. So methanol. And this is ethanol, eth because 2 carbon compound. So CH3 CH2OH, this is ethanol. They both are alcohols. The hydroxyl group are attaching to aliphatic systems in both the molecules. Now, if we specifically talk about the phenol, phenol also contains hydroxyl group, but it attaching to the benzene ring directly, or you can say hydroxyl group is attached to the carbon of the benzene ring, aromatic ring. For example, you can see this hydroxyl group, OH group is directly attached to this unsaturated system of benzene ring, and this is called phenol. Okay, phenol. And the another example given is metacresol, where at the very first position we have CH3, and at this you can say meta position we have OH group. Okay, hydroxyl group. So that's why the name is M-cresol, that means metacresol. Okay, meta is specifying this position. So this is para, these both are equivalent ortho, and these are meta positions, this one, and this is para position. Okay, so because our hydroxyl group is present at hydroxyl group is present at the meta position, so we are calling it as metacresol. They both comes under the category of phenols. Now let's talk about their classifications, the section 7.1. So classifications of alcohols, phenols and ethers. Alcohols are classified based on the number of hydroxyl groups they contain, also the number of carbon atoms they are directly connected to the carbon that holds to the hydroxyl group. Okay, so basically you can classify the alcohols based on that in a alcohol how much hydroxyl group is present, the number of hydroxyl group they are containing, and also you can classify it on the basis of the number of carbon atom are directly connected to the carbon that holds the hydroxyl group. That means if the hydroxyl group is attaching with the carbon, that carbon is attaching with how much carbons. So on that basis also we can classify the alcohols. If we talk about phenols, phenols are classified by first of all the number of hydroxyl groups which are directly attached to the benzene ring, and this is the classification of phenols. On the other hand, ethers are categorized as simple ethers, or you can say symmetrical ethers, where both the groups both the alkyl groups attached to the oxygen are identical. So oxygen is in center, and two alkyl groups are attaching to that oxygen. Okay, so if those two groups of alkyl are identical, they are same, then we call that ether as simple or symmetrical ether, and the other ether is other type of ethers is mixed ethers, the opposite of simple ethers. You can also call it as unsymmetrical ethers, where the two alkyl groups which are attaching to the oxygen are different, they are not identical. Then that ether will be mixed or unsymmetrical ethers. Now let's talk about specifically the section 7.1.1, that is alcohols, in which we will talk about mono, dia, tria or polyhydric alcohols. So alcohols are classified on the basis of number of hydroxyl groups attached. We just have seen, right, that how many number of hydroxyl group is present in a molecule, in a alcohol. We can classify that on this basis. So the first is monohydric. So classification of alcohols on the basis of the fact that how much number of hydroxyl groups is attached in that molecule. We are classifying them first as monohydric. Mono means single, and hydric is as the name says, hydrogen. Okay. The other one is dihydric. Dia means two, and the next is trihydric. Tria means three, and the fourth one is polyhydric. Poly means more than three, you can consider. Okay, poly means so many. So monohydric contain one hydroxyl group. Okay, one hydrogen and one hydroxyl group. So mono means one. So alcohols where the number of hydroxyl group is one, they are monohydric. And for example, methanol and ethanol. You can see the first one, that is methanol. This is a alcohol containing one hydroxyl group. The second is ethanol. This is also containing only one hydroxyl group. So that's why they are monohydric. Second one is dihydric. Dia means two. That means simply the alcohol will contain two hydroxyl groups. For example, ethylene glycol and propane 1,3-diol. You can see the hydroxyl groups are present at the adjacent carbons of this molecule, right? And the name is ethylene glycol. Okay. You can also call it as vicinal alcohol, right? And the another one is propane 1,3-diol, where again the hydroxyl groups are present at the different carbons, and the two number of hydroxyl group is present. So this comes under the dihydric alcohols. So continuing on this, the third is trihydric, based on the based on the fact that how much number of hydroxyl group is present in an alcohol. The third classification is trihydric. Tria means three. That means the alcohol is going to contain three hydroxyl groups. For example, we have pentane 1,3,5-triol. That means at very first, at the third and the fifth carbon, we have hydroxyl groups attached in a 5-carbon chain compound. So we are calling it as pentane 1,3,5-triol, and this comes under the trihydric alcohols due to the presence of 3 hydroxyl group in it. The other example is propane 1,2,3-triol, or the common name is glycerol. Okay, so 3 hydroxyl group is present in this molecule, hence the name is propane 1,2,3-triol, and this comes under the trihydric alcohols. The next is polyhydric. Poly means so many. So the definition is that it will contain more than 3 hydroxyl groups, because until 3 we are calling them as trihydric. So more than 3, if any number of like 4, 5, 6, 7 up to n, if any number of hydroxyl group is present in an alcohol, then we call them as polyhydric. So for example, it's very, very famous, glucose and fructose, right? We study them in biomolecules chapter, right? In the later upcoming lectures, we will also study them in detail. So glucose has, you can see this structure. This is open chain structure of the glucose, and this is for fructose. You can see there various number of hydroxyl groups are attached to the carbon in this glucose. 1, 2, 3, 4, and 5. Okay. So 5 number of hydroxyl group is present in the glucose, which is more than 3. So this comes under polyhydric alcohols. And similarly for the fructose, where 1, 2, 3, 4, 5 hydroxyl group is present, more than 3. So this is also polyhydric alcohol. Okay. Glucose and fructose, they both are sugar. As remember, we have said that the alcohols are found, the hydroxyl compounds are found in sugars. Compounds containing carbon sp3 hydroxyl bond. So hydroxyl group, that is OH group, attached to the sp3 hybridized carbon in the alcohols. Okay, and they are classified as primary, secondary, and tertiary alcohol. So in the alcohols, we don't have any carbon sp2 hybridized. Okay, so the hydroxyl group which is connecting with the carbon, which is bonding with the carbon, is actually, that carbon is actually sp3 hybridized, and they are classified as primary, secondary, and the tertiary alcohols. So let's see them one by one. What are primary alcohol? Where hydroxyl group is attached to a primary carbon atom. An alcohol where hydroxyl group is attached to the carbon, which is primary in nature. Or you can say hydroxyl group is attaching to the carbon, which is only attaching with one other carbon, then it will be a primary alcohol. For general formula, you can say it is bond CH2OH. Now, with this CH2OH, only one carbon can bind. Okay, so this is a general formula for a primary alcohol. The example is ethanol and propanol. So in the ethanol, the hydroxyl group is attached with this carbon, and this carbon is attaching with one other carbon. So this comes under primary alcohol. And similarly for the propanol, this hydroxyl group is attaching with this sp3 hybridized carbon. This is attaching with other one carbon. So this is a primary alcohol. Example, propanol and ethanol. Then let's talk about the secondary type of alcohol. Secondary alcohol means the hydroxyl group is attaching to a secondary carbon atom, or you can say hydroxyl group is attaching to the carbon atom which is attaching with other two carbon atoms. General formula is bond, and here comes a bond, and then CH, single bond OH. Okay, so hydroxyl group is attaching with this carbon, and this carbon is going to attach with other two carbons. So this is a general formula for a secondary alcohol. Example, propane 2-ol and butane 2-ol. In the propane 2-ol, you can see this is secondary alcohol. The hydroxyl group is attaching with this carbon. This carbon is attaching with other two methyl groups carbon. So this is secondary alcohol. And similarly butane 2-ol, where this hydroxyl group is attached to this carbon, and this carbon is bonding with other two carbons. So this is also a secondary alcohol. Now the tertiary alcohol. Tertiary alcohol in which hydroxyl group is attached to a tertiary carbon atom, or the carbon atom which is attaching with other three carbon atoms. So they are tertiary alcohols. The general formula for tertiary alcohol is C, making 3 bonds with another substituents and 1 bond with the hydroxyl group. Okay, so hydroxyl group is attaching with the carbon which is making the bond with other 3 carbons. So this is the general formula for tertiary alcohols. And if you see the example, the first is 2-methyl propane 2-ol, hydroxyl group attaching with this carbon, and this carbon is a tertiary carbon because it is attaching with other 3 carbons. Similarly, the other example, 2-methyl butane 2-ol, the tertiary alcohol, where this hydroxyl group is attaching with the carbon, this carbon is attaching with other 3 carbons. So this is a tertiary alcohol. Now, if we talk about allylic and benzylic alcohols. So allylic alcohols means hydroxyl group attached to sp3 hybridized carbon, which is adjacent to a C double bond, C. Or you can say that hydroxyl group is attaching to a sp3 hybridized carbon, which is attaching with a double bonded carbon atom. Okay. They are also classified as primary, secondary, or tertiary. For example, the primary allylic alcohols, where the hydroxyl group is attaching with this carbon, which is sp3, and this carbon is attaching with a double bonded carbon atom, and the hydroxyl group is attaching with this carbon, and it is attaching with only one carbon. So this is primary allylic alcohols. Okay, two concepts we are mixing. Now this is secondary alcohols, secondary allylic alcohols, because the hydroxyl group is attaching to a sp3 hybridized carbon, which is bonding with a double bonded carbon atom, and the hydroxyl group is attaching with the carbon, and that carbon is attaching with other two carbons. So that's why this is secondary allylic alcohols. Similarly, tertiary allylic alcohols, where hydroxyl group is attaching with the sp3 hybridized carbon atom, which is attaching with double bonded carbon atom and three other carbon atoms. So this is a tertiary allylic alcohols. Then comes the benzylic alcohols, where the hydroxyl group is attaching to a sp3 hybridized carbon atom, which is adjacent to a aromatic ring. So benzylic comes from the benzene ring, aromatic ring. So hydroxyl group is attaching to a sp3 hybridized carbon atom, because we are studying alcohols, not phenols, right? So hydroxyl is directly attaching to a sp3 hybridized carbon atom, but that carbon atom is adjacent to a aromatic ring, or that carbon atom is binding to the carbon of benzene ring. They are also classified as primary, secondary, or tertiary. For example, this is the primary benzylic alcohol, because hydroxyl group is attaching with the sp3 hybridized carbon atom, which is adjacent to an aromatic ring, and also the hydroxyl group is attaching with the carbon, which is attaching with one other carbon. So this is primary benzylic alcohols, and similarly this is secondary benzylic alcohols. Hydroxyl is attaching with this sp3 hybridized carbon, which is attaching with other two carbons. The one is this one, and the other is the carbon of aromatic ring. So this is secondary benzylic alcohols, and this is tertiary benzylic alcohols. Hydroxyl is attaching with this carbon attaching with other three carbons. Two are the substituents, and one is the carbon of aromatic ring. So this is tertiary benzylic alcohols. Now let's see the compounds that containing carbon sp2 hybridized single bond OH bond. Okay, so that means carbon hydroxyl bond, but the carbon is sp2 hybridized. So they are classified on hydroxyl group attached directly to doubly bonded carbon. Okay, so that means in these compounds the hydroxyl group is directly attaching to a double bonded carbon. Okay, the first comes vinylic alcohols, where hydroxyl group is attaching to a carbon atom of carbon double bond carbon bond. Okay, that means the hydroxyl group is directly attaching with the sp2 hybridized carbon atom of double bond carbon. For example, we have this molecule CH2 double bond CHOH. Okay, so we have, you can say, hydroxyl group attaching with this carbon, which is sp2 hybridized, and also a double bond carbon. Okay, the another example is of this molecule, where CH3 is CH double bond CHOH. Hydroxyl is present on this carbon, which is sp2 hybridized and a double bonded carbon. The next category comes as phenols. In the phenols also the hydroxyl group is attaching to a carbon sp2 hybridized, right? So OH group attaching directly to a carbon atom of an aromatic ring in the phenols, which is sp2 hybridized. For example, we have this phenol, the very common hydroxyl group is attaching with the carbon of aromatic ring. Next is orthocresol. At the ortho positions we have hydroxyl group, para position we have methyl group, and we have benzene ring. Metacresol, just we have changed the position of hydroxyl group from ortho to meta. And the last is paracresol, where the hydroxyl group position becomes the para. Okay, so these are the phenols, where hydroxyl group is directly attaching to a carbon atom of aromatic ring. So now let's talk in detail about the phenols, the section 7.1.2, in which we will cover the mono, dia and trihydric phenols. let's talk about the classification of phenols. So they are classified on the basis of number of hydroxyl group attached to the benzene ring. So they are termed as monohydric if the hydroxyl group number is 1 in the phenol. If the number is 2, that means 2 hydroxyl group is present, then it will be dihydric. If 3 hydroxyl group is present, then it will be trihydric. For example, this phenol is a monohydric. This 1,2-dihydroxyphenol is dihydric, and this 1,3,4 trihydric phenol is actually trihydric because 3 number of hydroxyl group is present in this benzene molecule, or you can say 3 hydroxyl group is directly attaching with the carbon of benzene ring. Okay, so this is trihydric. Tri means 3, di means 2, and mono means 1. Now in this phenols, we cannot classify them as polyhydric phenol, right? Why is it so? Because poly means that you are attaching here also, here also, here also, right? But that's not possible because, as I said, this is para position, this is para position, this is meta position, this is meta position. They are equivalent. They are ortho and ortho. They are also equivalent, right? So that's why we are classifying only phenols into the 3 classes: the monohydric, the dihydric, and the trihydric. Okay. Okay, now let's talk about our another class or another topic of this chapter, that is ethers. The section 7.1.3. Let's talk about its definition and classification. So ethers are formed by replacing the hydrogen atom in the hydroxyl group of an alcohol or phenol with an alkyl or allyl group. So what will happen? Hydrogen atom will be replaced in the hydroxyl group, and alkyl group or alkyl group will add up to the oxygen and forms the ethers. Okay, so from the alcohol or the phenol hydroxyl group, hydrogen atom will be removed, replaced by the alkyl or aryl group, and you will get an ether. The general formula includes ROR prime, where this R and R prime may or may not be same. They may be same. If they are same, then we got symmetrical ethers. If they are not same, then we will get unsymmetrical ethers. They are classified as symmetrical and unsymmetrical, as I just said. Symmetrical ethers, where the R and R prime, both alkyl or aryl groups, are same. So same group present on both sides of oxygen atom, then they will be symmetrical ethers. If, for example, we have oxygen attaching with 2 R groups, okay, the both R is same, the benzene ring and benzene ring. So the name is diaphenyl ether, because both the benzene ring, like both the R is same, attaching with the oxygen at both sides of the oxygen atom, then we are considering this as symmetrical ethers. The another example is diethyl ether, where oxygen is attaching with the 2 ethyl groups, right? The both are same, so this is diethyl ether under the symmetrical ether. The another type is unsymmetrical ethers. Very simple. Both the R will be different. R and R prime will be different. They are not same. So different group is present on both sides of oxygen atom, then we will consider it as unsymmetrical ethers. For example, we have this oxygen attaching with the ethyl group and methyl group. So this is ethyl methyl ether, and this is unsymmetric because ethyl and methyl both are different. The another example is methyl phenyl ether, where at one side of oxygen we have benzene ring, at another side of oxygen we have methyl group attaching with the oxygen. So this is unsymmetrical ether. R prime both are different. Okay, now let's practice an in-text question. The in-text question 7.1. Question is, classify the following as primary, secondary and tertiary alcohols. So we have given some 6 molecule structure. You have to classify them whether they are primary, secondary or tertiary alcohols. The first one is C, CH3, 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 CH2OH. The second one, CH2 double bond CH, single bond CH2OH. Third one, CH3, CH2, CH2OH. Fourth one, we have benzene ring attaching with CHOH, CH3. Fifth one, we have benzene ring attaching with CH2, CHOH, CH3. And the sixth one is benzene ring attaching with CH double bond CH, C, CH3, CH3, OH. So you have given some time, try to analyze this question, and then we will see the correct answer for each of the part. Okay, let's see. So for the primary, secondary, and tertiary classification, let's understand the primary alcohol. Primary alcohol having carbon bonded with hydroxyl group and it is attaching to only one carbon atom. Then we will classify that alcohol as primary alcohol. So the first molecule is CH3, 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 CH2OH. Okay. If you observe, the hydroxyl group is attaching with this carbon, which is bonding with other one carbon only. Okay. These three methyl groups are attaching with this carbon, not this carbon. Okay. So this carbon is attaching with two hydrogens and one carbon. Okay. So that's why we are calling this alcohol as primary. So the alcohol present in the first part is the primary alcohol. And the second part also, if you see, because it is allylic alcohol, right? But still, we only have to classify the alcohol on the basis of the carbon nature at which the hydroxyl is present. Okay, that means primary, secondary, and tertiary. So on the basis of that fact, the second part has CH2 double bond CH, CH2OH. So hydroxyl group attaching with the carbon, which is attaching with other one carbon only. So this is also a primary alcohol. Now, if you see the third structure, CH3, CH2, CH2OH, butanol, right? So, hydroxyl is present at this carbon and this carbon is attaching with one other carbon. So, this is also a primary alcohol. Now, secondary alcohol. Secondary alcohol will be where the carbon atom is which is bonded with hydroxyl group is attached to only two other carbon atoms. So if you see the fourth structure given, we have benzene ring attaching with CHOH-CH3. Now if you focus on the primary, secondary and tertiary concept, the hydroxyl group is attaching with this carbon and this carbon is attaching with other two carbons. One is this methyl group carbon and the other carbon is of this benzene ring. So that means this is a secondary alcohol. The fifth molecule given is benzene ring attaching with CH2, CHOH, CH3. Now again on the basis of concept of primary, secondary and tertiary classification of alcohols, the hydroxyl group is attaching with this carbon, attaching with only other two carbons, this methyl and this CH2 carbon, right? So this fifth structure is also a secondary alcohol. Now, for the tertiary alcohol, where carbon bonded with the hydroxyl group is attaching to only three other carbon atoms. The sixth structure given is the only structure which is tertiary alcohols because the benzene ring attaching with CH double bond CH, C, CH3, CH3OH. Now, we just have studied the tertiary alcohol concept. On the basis of that, we can see that OH group, the hydroxyl group, is attaching with this carbon. This carbon is attaching with other three carbons, right? This two methyl groups carbons, and one is this sp2 hybridized double bonded carbon. Okay, so this is also a tertiary alcohol. So this is sixth structure is the only structure which is tertiary alcohol. So this is how you can classify the alcohols in primary, secondary, and tertiary alcohols. Let's see the next question in text question 7.2, which is identify the allylic alcohols. So we have given again the sixth part of this question. First part is CH3, 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 CH2OH. Second is CH2 double bond CH, single bond CH2OH. Third is CH3, CH2, CH2OH. Fourth, benzene ring attaching with CHOH, CH3. Fifth, benzene ring attaching with CH2, CHOH, CH3. And the sixth part, the benzene ring is attaching with CH double bond CH, CH3, CH3OH. Okay. So these are the 6 different structures or molecules or alcohols given. You have to identify the allylic alcohols. Remember the concept of allylic alcohols, and you have given some time. Try to analyze each part and then we will see the correct answer. Okay, let's see. So first of all, let's understand what is allylic alcohols. Allylic alcohols containing hydroxyl group which is attaching to the carbon next to carbon double bond carbon. Okay, that means hydroxyl group is attaching to a sp3 hybridized carbon atom which is attaching with the double bonded carbon. If you see the second structure and the sixth structure, in the second structure we have hydroxyl group attaching with this sp3 hybridized carbon, and this sp3 hybridized carbon attaching with double bonded carbon. This is what allylic alcohols are, right? So the second structure of the molecule of the alcohol is an allylic alcohol. Similarly, in the in the part 6th, we have benzene ring attaching with CH double bond CH, single bond CCH3 CH3OH. Now here also the hydroxyl group is attaching with this sp3 carbon, and this carbon is bonding with the double bonded carbon, right? So this is also an allylic alcohol. Compound first and third does not have any carbon-carbon double bond, but for the allylic alcohols it is necessary to having carbon double bond carbon in the structure, right? But in the compound first and third, it does not have any carbon-carbon double bond. You can see the first is very like the primary alcohol, and the third is again a primary alcohol and doesn't contain any double bond. If you see the compound fifth contains the double bond, but the hydroxyl group is not attached to the carbon which is next to carbon double bond carbon, right? So if you see the fifth structure, the hydroxyl group is attaching with this carbon sp3, but this carbon is not attaching with a double bonded carbon, right? It is attaching with only the single bonded carbons. So this is also not the allylic alcohol, and the double bond is present in this molecule in the benzene, but still this is not allylic alcohol. The fourth structure remaining, hydroxyl group in the fourth structure is attached to carbon which is next to the carbon double bond carbon bond of benzene. Therefore it is benzylic alcohol. So in this structure of fourth compound, you can see that hydroxyl group is attaching to the carbon which is attaching with the carbon of benzene ring, right? Hydroxyl group is attaching with this carbon, and this carbon is attaching with the carbon of benzene ring. And on the basis of the concept of benzylic alcohol, we have seen this fourth compound is actually a benzylic alcohol, because as per the definition, hydroxyl group is attaching to the carbon which is attaching with the carbon of benzene ring, and that are called benzylic alcohol. So this is not allylic alcohol, but it is benzylic alcohol. That's why we cannot say that the fourth compound will be the allylic alcohol. So only the first, third, fifth, and second will not be allylic alcohols. And you can say that the sixth one and the second one structure is only the allylic alcohol in the given question. Okay, let's see the summary. What we have covered today. First of all, we have seen the points to remember. Alcohol versus phenols. So we have seen that alcohol have hydroxyl group, which is attaching to aliphatic carbon, saturated carbon. Phenols have OH attached to aromatic ring, that is benzene. Okay, this is the difference between alcohols and phenols. Then we have seen the classification of alcohols, like based on the number of hydroxyl groups. If you classify them, they will be monohydric, containing one hydroxyl ion, dihydric containing two hydroxyl ions, trihydric, the alcohol containing three hydroxyl ions in a single molecule, and polyhydric means more than three hydroxyl group is present in a molecule. Second classification is based on the carbon attachment to the hydroxyl group. So if hydroxyl group is attached to a primary carbon, it will be primary alcohol. If hydroxyl is attached to secondary carbon, the alcohol will be secondary alcohol. And if the hydroxyl group is attaching to a tertiary carbon, the alcohol will be a tertiary alcohol. So based on carbon attachment, the alcohols are classified as primary, secondary, and tertiary. Another points to remember, we have seen the special types of alcohols like allylic one, where hydroxyl is present next to the carbon-carbon double bond. The benzylic alcohols, where hydroxyl is present next to the aromatic ring. And vinylic alcohols, where hydroxyl group is directly attaching to carbon double bond carbon. And then we have seen the classification of phenols, where phenols are classified based on the number of hydroxyl groups that are attached to the benzene ring. On that basis, they are classified as monohydric, dihydric, and trihydric. Okay, monohydric means only one hydroxyl group is attaching to benzene ring. Dihydric, two hydroxyl group attaching to benzene ring, and trihydric, three hydroxyl group are attaching to benzene ring at the different positions of the benzene ring. Then we have seen the classification of ethers. The general formula for ethers is ROR, the general representation. R and R prime may or may not be same. So the classification of ethers are based on the type of group attached. Either they are same or they are different. We are talking about alkyl or aryl group, that is this R group. So they are classified as symmetrical if both the groups present at both sides of oxygen are equal, are same. If R equals to R prime, then they are symmetrical ethers. If R is not equal to R prime, both the alkyl or the aryl groups are not same, they are different, present at both sides of oxygen, then that ether will be unsymmetrical. Now here R and R prime can be alkyl or aryl, both groups. Okay, either benzyl group, either ethyl, methyl, alkyl group. Okay. Okay. Thank you so much. That's all for today's chemistry session. Thank you.